So dear colleagues, welcome everybody online and in presence. Okay, recording is in progress. So the first thing to say is that if you don't want to be on the recorded video, please switch your camera off. And of course, in the room, we have already got the no camera zone. So welcome everybody again. This is our first hybrid seminar in this ACASTEMI project. It's titled Health and Medicine. That's our module to be developed, the same title, with the same title in this project. And therefore, we are very glad to welcome the representatives of two pharmaceutical companies and also, of course, all the colleagues who are interested, including practicing STEM teachers. So the first welcome speech is by István Szalai, the director of the Institute of Chemistry at the ELTE University. István, the floor is yours.
Okay, thank you, and it's really a pleasure for me to open this meeting and welcome you, guests and colleagues here. As Luca told you, I'm the director of the Institute of Chemistry at the Eötvös Loránd University. At least in the room, I see most of you know very well this university, but I have to say some words about our university. Sorry for those who know very well, but not all of you. So, in simple, we say that the Eötvös Loránd University is the oldest, and the largest university in Hungary. But these are just words. What does it mean? Oldest means for us, I think, that we have a long-lasting tradition in education of science, humanities, laws, and other fields as well, and also in research. And this tradition, so we have now the task is, for us is to serve this tradition. So we have to continue this and to do it as perfectly as possible. And what does it mean largest? The largest means that if you count the numbers, number of students, number of academic professors, I don't know, the largest number belongs to the Eötvös University, at least in Hungary. But most importantly, a large majority of the Hungarian high school students choose our university. So they trust us. That's very important. So we have to serve these students because they trust us, so we have to give the best education what we can. I think this is why we are here. Concerning the science faculty and the Institute of Chemistry, we believe in research-based education. So we try to push, I would say, or force maybe even our students to start to contribute to research from the beginning, so even from the first semester, which is difficult, but I think this is the best way what we can do nowadays. So we teach, of course, or we educate the next generation of researchers. That's one of our primary goal. But there's a second one, and I would say it's equally important or even more important. We teach the next generation of the high school teachers in chemistry, in physics, mathematics, whatever. And I would say it's equally important or even more important because if we want to have some students to study, to learn research, chemistry, then the most important thing is the first meeting of these students with science, with chemistry. And the first person, typically, who really meet the students at the high school, these teachers. So if we educate well the teachers, then we will have students who are willing to study at least chemistry or science. And then we might have a chance really to to serve the next generation of the researchers as well. So everything starts with the teachers. So this is why the education of the high school teachers is very important for us. 2 years ago, or maybe almost 3 now, we can say, yes, we just renewed our program for the chemistry teachers. And the main goal, the main idea is that to separate from the chemistry students who wants to be researchers, because for each subject, organic chemistry, analytical chemistry, physical chemistry, we believe that we teach this subject differently from those who will be the teachers in high schools and for those who will do some research and maybe work in the industry. So we try to do this, and we try to monitor continuously the progress of this new program, and it seems that it works well, at least until now. What we need, of course, we need a little bit more students. I don't know but I think in this, for this committee, it's not new that we have a lack of chemistry students, who wants to be chemistry teacher. But also if we want more, I think we have to focus on, and we have to discuss the possibilities, not only, but importantly with the member of, the representative of the industry, but also the teachers who are in the high schools right now. So I hope this meeting will help in this and to shape a little bit the next generation of teaching of the teachers. So I'm really happy to be here, and I hope that this meeting will contribute to this. Thank you.
Thank you, István. Now, the next welcome speech is done by Mia Ranikmey, who is the leader of this consortium. Mia, may I ask you? Okay, may I ask you to start?
Yes. So thank you, Luisa. And my first welcome and biggest congratulations are coming towards Hungary. And on behalf of the whole consortium, may I actually thank very much Edina and Luisa to organize such a wonderful event, which is a pioneering event during the life of our project. We have actually planned more similar hybrid meetings, but this is the very, very, very first one. And Hungarian partners done wonderful work to get all of us together during the time when the weather is nice outside, during the time when some of us already have holidays. And I can see a lot of Hungarian teachers ready to listen to an interesting lecture. Just few words about our project. So the project is connecting many European countries. Many of countries which have been working together many, many years over several projects. And here can I say that Portugal, Germany, Finland, Estonia, Hungary, Croatia, Latvia, everybody is here and with smiling faces. And these are the partners who will take lead of creating our project major products, which are creating modules for teachers, future usage. And today's lecture is part of that and will be translated to all our languages and is accessible to those who cannot be present today and who may not be able to understand English so well. And then these discussions will be continued in partner countries. But not only modules, we are working also towards micro degrees, towards job shadow visits with our partners and industry. And we also do deal with joint supervision of master thesis. And my last point is I would like to emphasize the topics where we are working strongly now. So the first and very important topic is health and medicine, which is strongly related with chemistry. And here is a flag given to Hungary to start. Then we are also dealing with medicine and with Green Deal, with diversity, with CMAP, with sustainability, with psychology, and all these topics form our consortium the list of interesting modules and topics which way to go. So Luisa, I thank you giving the floor to me, and I don't want to use valuable time of the main presenter. Thank you.
Thank you very much, Mia. And now, first, I'd like to show you a few slides just to introduce this project briefly in a bit more details with a bit more facts, as Mia had already told you about. So this is the name of the project and the acronym, and also the title of today's seminar. This is a series, as Mia said. The first one of this series, STEM Step Up, and there will be several others, but today we are concentrating on the health and medicine topic because that's our main responsibility in this project. So, yeah, okay, sorry, forgot that. So the other next parts of the program, after me introducing the partner institutions, the goals and objectives of this project, there will be two talks or two combined talks on the two associated partners, the Richter Pharmaceuticals and the Aegis Pharmaceuticals companies, and they will let us know how they can help us to achieve our goals and what they can do. And later on in the afternoon, after this English part of international part of this program is finished, with the Hungarian colleagues we will have small group discussions, and we collect ideas about what the teacher colleagues would expect of us to do, what their needs are concerning the content of the modules, also how they would like to, if we organize this mobility schemes, how they could participate and what our partners can offer. So after that, we will summarize it all, and that will be the outcome of this today's meeting. So we collect ideas and we systematically publish it later, and that will be the ground of developing the module and to organize the mobility programs. So here are the universities, the 7 universities who are partner institutions in this project. There is also a research institute and a non-profit organization, so 9 partners from 8 different countries. And here is a picture, a photograph taken at our first meeting in Tartu last September. So the main goal is, and this is a quotation from the application of the project, which says, as you can, I will not read it out, of course, but it's mainly we want to provide a research-based support for the STEM teacher education which is mainly developing modules for CPD courses, and that could also be used in pre-service teacher education, and models for the mobility project. And as you can see, not just only the universities are participating, the teacher training universities, but also STEM teacher associations. The representatives of ministries of education are also involved. I have been in contact with the authorities, how can we do, for example, the micro-credentials built up from the modules that we are developing. And even the Academy of Sciences are involved in a way. So this is just a news item that I found on our university website last Sunday, and then I inserted it into this presentation. And of course, it's in Hungarian, but I translated the title, which is enough for us for the moment, an alarming picture of the health behavior of Hungarian adolescents. So there you are. They need our help. They need your help to work out how to explain to the students what they should do and what they shouldn't do in a way that is supported by science, that is supported by the research, not just these sort of pseudoscientific sort of advertisements that they can read everywhere nowadays. We have to fight against that. So concrete objectives, as Mia has already told you, distance and blended learning modules for CPD courses mainly, continuous professional development courses mainly, 6 of those modules, and also the mobility model that we try, and it works. So we have to work out how to do it, and then we have to try it. The modules, and I just show you quickly these 6, the topics of these 6 modules, and I highlighted the health and medicine, the very first one in yellow, because that's our responsibility, as I already mentioned. So we have to develop the teaching materials, the structure, how it can be done, pilot it with teachers, real living teachers, and after that we have to summarize our experiences and finalize the whole thing, and then we have to make sure that there are micro-credentials as well that we can issue, the universities can issue after finishing these courses. Here I just show you as prompts for today's discussion, the health and medicine part of our questionnaire that we put together in this project, and many of our teacher colleagues have already filled it in. 84 Hungarian STEM teachers and pre-service teacher students have already filled this in, and many others will fill it in other countries. And we asked our colleagues about their needs, how do they feel with this self-evaluation answers. They could let us know what they think, how much they know about these science territories when it comes, for example, to the molecular basis of the healthcare and the pharmaceutical, the production of medicines and so on, and how the immune system works. So how do they feel? How much they can explain? How much do they know about it? How much they can explain to their students? These are the fancy new territories. You see the biochemical processes, the newest development, the biotechnology, the gene therapy, and so on. Where can they this interdisciplinary knowledge, how much they would need to learn about this so that they could teach it effectively. And I don't read it out now because we are running out of time, but these are also the other issues that we ask the teachers about. And okay, just one more slide. So we could offer in these worksheets developed in another project financed by the Hungarian Academy of Sciences, students' worksheets that include experiments, student experiments, and they are developed with teachers' guides and everything, and they are tried and tested. The ones that are written in red and the ones that are written in blue will be developed this summer and tried and tested in the next school year. So we can offer these if the teachers think that they are worth to be included in this module, then we can use these as well. So these are just prompts for the group discussions. And now, thank you for your attention. And our next talk is given by Csaba Szántai, our Associated Partners representative here. And Csaba, please.
Thank you, Luca. Once again, it's a real pleasure and also an honor to be here. Not just because I'm representing Gideon Richter, a huge company, but also because I feel I serve a mission here among people who also serve a mission which is very important. So it's cool. Okay. Just a few words about Richter so that you get a preliminary idea of what this company is all about. I'm not going to read these words out. Just absorb them, please, as quickly as you can, because I'm running out of time. And a few pictures. Okay? This is our central building at Gideon Richter. It looks cool, doesn't it? Okay? From another angle as well. Okay? These are the staircases. You see innovation. We breathe innovation all the time. Okay? Workplaces inside the building. This is our central research chemistry building. Looking at this building from the other side, I would like to point out these structures here. These are the cones that hide our NMR, nuclear magnetic resonance instruments. The point that I'm trying to make here is this is one particular facility that we can show to teachers if they come to our place. Staircases, innovation, okay, same thing. Staircases again. Okay. And we have a visitor center as well, which is also something that we can show to teachers, and they're very instructive. A few words again about the uniqueness of this company. Again, I'm not going to dwell on this. It's just something for you to get an impression about. The point that I'm trying to make here is nothing, and I mean nothing works without this, the talents that are coming out of the educational system. Gideon Richter is non-existent without the educational system. Okay, it's very important. But what is also important is that we have to understand the term talent, and I'm going to get to that in a minute. An obvious question that teachers should raise at this point, what is the knowledge that Gideon Richter can offer technically for them, that they can bring home, that they can build on, and they can use in their own teaching? That's the obvious question here. And it's a valid question, and we're going to discuss this in the small group sessions. But there's an underlying question as well, which is probably even more universal. And this question is valid also from the perspective of the company. And I'm talking about Gideon Richter here, but you can use that as a metaphor for every for-profit big company who use talents, okay? And this question is the following. What is the true nature of a real life R&D lifestyle and the true meaning of talent in reality in this environment? And the interesting thing, what we see here is, here's a gap, okay? So the educational system typically doesn't really understand this. That's very, very important to bridge this gap. So if we don't address this question, then there's not much point in going to this question because, it will have limited effects to just only talk about this one. Yeah, I love this. There's this English saying, people are like tea bags. You never know how strong they are until you put them in hot water, right? The pharma industry is hot water. So believe me, talent is tested there. Hard stuff, okay? Very, very important. It is in this spirit that I'm going to give you this rather short presentation with the initial idea to let you know that we are trying to support educational institutions, students, teachers, as well as all sorts of educational activities. So these are the main 4 areas. And I'm going to focus now on this question primarily, but not forgetting the second question as well. I can come up with a subtitle. We are nurturing talents. Now you may wonder what the frog is doing here and what the hand. Okay, hand is nurturing the frog. The hand is blue because Richter is blue. Okay, that's obvious. But what the frog is doing here is not so obvious. But it will be obvious to you very soon, I'll promise that. So here's the educational system. And here we are, Gideon Richter, again as a metaphor for all for-profit innovation-based companies. And we have always, and I mean always, supported quite heavily this segment of the pyramid, as well as this segment. We also took care of secondary school teachers. But that was, less of a focus. We're mostly focused on this area. And what we see is the output in terms of talent is dwindling, to say the least. We're just kind of right before starting to panic about this. But before we are really panicking, we started to do something serious about the whole situation. And so we came up with a new mindset. And this mindset says, let's engage differently and more deeply in public education as well as in higher education. And the emphasis is here, public education, going down to secondary school more deeply, more intensively, and even going down to primary school. This is a general trend, obviously, for many companies that we see today. And I think teachers must be aware of this paradigm shift of how companies are relating to these areas. It's very, very important. But in order to do this well, for us, we must first understand what the problem really is and what talent really means. Okay? The reason I'm pointing this out is because there's a huge illusion about these terms. It seems so obvious, what talent means and what the problem is, and in reality, it's not. So we have to understand this more. What is talent? Here we go with the frogs, okay? Soon. Talent, this is an illusion. He's born to be a researcher. That guy is not born to be okay, fair enough. Fair enough. This guy, Homer, will never be a researcher, obviously. But the situation is not that simple. It's far more complicated. So here we go. Primary school, secondary school, university, PhD, okay? And real life. What is talent? In this region of the pyramid, we assess talent in terms of your mathematical skills, physical skills, physics skills, blah, blah. You know what I'm talking about, these sorts of things. And there's this illusion, that talent is this, and I mean talent with capital letters, red capital letters. In reality, this is only talent with small letters. And here we go to real life. This is it. Where the environment becomes totally different from what these little tadpoles experienced here under the water. And I would just give you a few ideas about this, what is happening in the pharma industry. I'm not going to go deeply into this, but it's tough. It's very much different from this situation. The fact is, talent in reality is this. Capital letter talent is this situation. And the illusion that we have, okay, so the point that I want to make here is school measures talent really mostly in terms of competition results and all these things, while the real-life workplace measures talent in the frog situation across a very broad range of skills that the frog should exhibit. Let me give you an example. Cariprazine, which is a very famous drug in Hungary for Gideon Richter. This is the molecule. It's a blockbuster. It's fantastic, I can tell you. I never took one, but it really, it's good. Okay, so it brings us a lot of money. And here's a picture. Here's a couple of data, okay, just to impress you. It's really big stuff. This thing has been going on since 1999. It's a huge time scale. And this is just a snapshot of the people who worked on this at one particular time. Several hundred people working on this situation at one single particular time. This is the success story. Okay, this is what the outside world sees. What the outside world doesn't see is all the intellectual and emotional effort that went into this. I know, I can tell you because I was deeply involved in the whole situation, and I tell you that in many, many cases we thought, okay, we're just going to give it up. It's impossible to go along with this. And it's hugely emotional to be able to believe in the cause and just go forward even if it doesn't seem to make sense. In reality, we have failed and running projects in original small molecule research. It's incredible. It's very, very difficult, not just intellectually, emotionally. And if you ask this question, who is capable of discovering and making cariprazine? This question is not the same question as who wins the math competition. It's a totally different question with a totally different answer. So how we view talent is this holistic picture. We have the cognitive skills and these attitude or emotional skills. This whole profile is what makes someone talented. And you know, some of these are quite obvious, but there are several ones that are not so obvious, and I'm again reiterating that many, many teachers don't see this because it comes from real life experience. And again, I'm not going to go into this, but this is one particular area where I think we could give a lot of information to teachers of how this works. And again, something I'm not going to dwell on here, but just a few statements about how talent really works with capital letters in real life. Okay, point to be made. This quality, tadpole quality, shining tadpole quality, is not the same as this quality. There can be a correlation, obviously, and we cheer for that correlation to exist. Right, but in many cases, this does not turn out to be this one, but instead we come from here to here. And also, in many cases, we have these not so shining tadpoles who turn out to be absolutely brilliant, brilliant, brilliant frogs. Let's not forget that. So what we mean by talent nurturing is helping these shining tadpoles to become truly shining frogs in this complex manner, and also helping these guys, the late bloomers, because we don't want to lose them. They can be incredibly good. So what is the problem? The problem has several components. One is the underfinanced system, which leads to a lot of other problems as well. The illusion here is that this is the problem. In reality, in spite of this problem, we do see a lot of absolutely great tadpoles coming out of the system. Brilliant, brilliant little chaps and kids. Fantastic. We can see that. Illusion number two, the key to solving the problem is let's rain a lot of money onto the system, and then it eliminates all our problems. Reality number two, the problem has other very serious components, which are less evident, less understood, and which still exist under heavy subsidy as well. One thing is this: teacher plus student ignorance about this difference. Okay? Institution, this is a VIP, an elite school that I'm trying to represent here. They're not really interested in raising golden frogs. They're interested in shining tadpoles because they are winning the competitions, even if that means that their psychological profile just goes down the drain during the process. They are unaware of this possibility, and they're not really interested in developing these talents. When they come to the job, what we see is that they shine. This is the shining part of the frog. They come with a lot of credentials, good competitions, everything. And the fact that they are psychologically not so okay, let's say, comes to light only much later. And they can, kill a team. I've seen this many, many times. Second, the need for wizardly teachers. Teachers are everything. The inspirations that they can provide is everything. We need to find them. We need to boost them emotionally, socially, in every possible sense. And fourthly, the educational system doesn't understand what is going on in pharma research and development. Okay? There's this general perception that academic research is what really needs the huge talents, and industrial R&D is really just wood chopping. And I'm going to show you, sorry about the rude words that I'm going to show you here, but it's complete crap. This is not true, absolutely not true. So we must work on this. We must work on this for the educational system to understand. Problem number 5, the negative aspects of digital age and social media influences. And again, let me not dwell on these sentences here. I think you understand the situation. A lack of long-term focus, which is the essence, one of the essences of being a good scientist. And I can go on with this forever and ever. No amount of money would simply solve this problem. So we have to work on this. So what do we do as Gideon Richter? Okay. Here are a number. I still have time. 45. I'm going on up to 45. That's 20 minutes. Yes, okay. So what do? We have a lot of plans. We have a lot of plans. But this is the main point, because this is what really concerns, I think, the present situation. And let me give you just a few examples during the 5 minutes that I still have. Okay. We came up with an open call for application system to support institutions in 2023. And this is the first time anybody ever did this in Hungary as a for-profit company. And as you see, we had 553 submitted applications. I won't even tell you for how much money. It's incredible what they wanted. Okay. But this was very, very interesting. And here we go, educating teachers to understand this part of their teaching and to understand this part of their teaching. And as an example, let me tell you that we have various awards given to secondary school teachers. We are trying to engage them in Richter's lifestyle. We even hold workshops for them. This is a picture taken of last year's workshop. They loved it, I can tell you. It was really, really interesting. So that's a very educational situation. And of course, we are targeting students as well in the same spirit. So these are, again, just a few pictures of how we bring them into Gideon Richter and try to make them understand these concepts. And the effect is incredible, I can tell you. I mean it. They are just stunned, okay, by the realization. And even teachers and students say, oh, come on, we never ever thought about this. This is something completely new. And, when you see the light coming up in teachers' eyes that, okay, now we have tons of feedbacks when teachers say, okay, now I understand why I'm teaching. as students are saying, now I understood why I'm learning. So that's really, because they see what is going on, 10 years ahead if they keep learning and keep teaching. And not just the next test or something like that. We have a very interesting project which is called this. I cannot really relate to you this in English. It's a story writing competition. Kids should write stories containing natural sciences elements. This is a fantastic success, and we even publish there the best novels or stories or fairy stories that they write. They are fantastic. There are incredible talents out there, I can tell you. Small talents that we want to make big talents. And we even published a scientific background to this, about in the way that, methodologically, educational methodologically, how this can affect students' attitude towards themselves and towards natural sciences. And just one picture about the award-giving ceremony at the Hungarian Academy of Sciences of this project, so that you can see the magnitude of the whole situation. Okay, we also established at Semmelweis University a Richter department, so that we're inside the university. We're teaching there, taking their Richter knowledge. And of course, we're trying to recruit what we call Richter ambassadors, guys that will help you in September, the teachers who come within this program to Richter. Take-home message. We need to do this together. Okay. 45. Okay, thank you. Okay. No, I still have 1 minute. Yes, I realize that. This is a short reflection on what Luca said, and I'm just pointing out in red, highlighting in red, the areas where we, as Richter, can, I believe, significantly contribute to the project. And, of course, the second question, obviously. So this is my thank you for the attention. Still 45.
Fantastic. It was very entertaining, Csaba. Really, really good introduction into this work. And now, Gabi and Balázs from the Aegis Pharmaceutical Company, they will give their presentation.
Thank you so much. So my name is Gabriela Tornocki. I'm the communications leader of Aegis Pharmaceuticals. We totally agree with your concept of the talents. But we would like to tell you some facts and words about the company, what we work for, and what this company can give you, what kind of activities we can give to this program. We have a common mission, what Csaba has already mentioned, but this is the mission of our company. We devote all our knowledge to serve people, enabling them to lead long and healthy lives. Pardon me, in English. So we are in the same boat, so we can work on that together. Just some words about the company. We are a vertically integrated regional pharmaceutical company. What does vertically integration means? It means that we do all kinds of activities what you see in the pharmaceutical chain. So we have research and development, activities from active ingredients to finished product development. And we do the productions as well here in Hungary. We do the research and development and all the productions here in this country. So we have a lots of sites in Budapest and at Körmend. You might know, and we do the sales activities in lots of countries all over the world. We have a long tradition as well as Richter does. We started our activities in 1913, so 111 years ago. And the first research laboratory was built at Aegis in 1932. So research and development has even a 90-year-old history at Aegis. And then you can see we changed the name, but we didn't change the activities, or we extended the activities what our company did and does, and we made lots of investment during the last 10 or 14 years regarding research and development sites and manufacturing sites in Hungary. Some numbers about our company. We have 4,500 colleagues, not only in Hungary, but in our affiliates in foreign countries. And what shall I highlight? That we have 177 product lines, and we focus on mainly cardiovascular and central nervous system diseases. What is our focus in this specific program? That as a vertically integrated company, we employ a wide range of STEM-based professionals, so we still need those talents what Csaba has mentioned. And we focus on cardiovascular and central nervous system, and we can contribute to the development of these teaching materials within this program. What kind of activities we have done so far because of the educational system? We see this kind of gap that we have to fulfill as an industrial company. We support universities and other initiatives financially and with our workforce as well to create educational toolkit for chemistry teaching and make these chemistry-based professions even more popular. We offer various programs. We have a kind of visitor center. This is the Aegis Science and Technology Center, where we invite groups of pupils and university students. It's not me, I think, somebody. And we also support some chemistry-related competitions. And now we just initiated a new program where we support a mentor program for chemistry teachers. We have just started. We have very good feedbacks on that, so we would like to continue. And we are committed to this current cooperation with your university. Some pictures about the visitor center. You can see that we have lots of new and sexy elements of the programs. So first we started with university groups, then we went to secondary school groups, and now we are even focused on the primary school students from the age of 12 and up to showcase them the nice things what the pharmaceutical industry can show them. We can offer visits to this center for this program for those who will participate in this program. And we can offer a kind of job shadowing, a light job shadowing program where our colleagues can tell about their work, how they work as a doctor or as a pharmacist or a biologist at a pharmaceutical company, what kind of skills they need for that work. And we have some initiatives on green chemistry, what we can showcase or demonstrate as well. And I would like to invite Balázs Folk, who is my colleague and then leads the drug substance development.
Thank you, Gabi. So at a pharmaceutical company, there are basically two main branches of activity: drug substance development and production, and drug product development and production. So drug substance means a chemical substance, drug product is a tablet or a capsule. Since drug substance is closer to chemistry, and then chemistry is the main topic now, and since I'm responsible for drug substance development, my couple of slides will focus on drug substance development and manufacturing. The main tasks of drug substance development is to develop a manufacturing process starting from lab scale up to plant volume for the whole chemical synthetic route. And this process should be robust, safe, as cheap as possible, so competitive in price, even in the Far Eastern, with the Far Eastern competitors, green as much as possible, and this has to result at the end in a high purity drug substance that meets the international standards. And the whole process as an end product of the development should be appropriate for use in the routine production for decades in certain cases, and it should be in line with the pharmaceutical good manufacturing practice, is abbreviated as GMP principles. Along with the technological development I have mentioned, there is a very important other task, is the analytical development. So it has to go hand in hand with the technological development. So the final aim is to develop analytical methods for the whole process in order to monitor the reaction steps, in order to analyze the batches produced, and to demonstrate the consistently high quality of the drug substance. And this developed method should be used in certain cases for decades for the analysis of routine production batches, because at the end of the day, no produced batch goes to the market without being analyzed, even if this product has been produced or manufactured for decades, and the expectation is that the quality of the today's production is just as good as it was yesterday and as it was 2 years ago. It's a faith that it's the case, but it should be proven by analytical methods, by measurements. So that you can have a view about the drug substance development and its stages, I have summarized this, the whole situation on this slide. So the story begins at a laboratory where we work with a quantity of substance ranging from milligrams to up to roughly 100 grams. Then it goes further to kilolab, where the batch size is about 1 or 2 kilogram as a maximum. You can see that in these first 2 stages we use glass reactors, while in the pilot plant, where the batch size is roughly ranging from 5 to 50 kilograms, already metal reactors are used. And after the pilot plant, the last scale-up step is the scale-up to large-scale manufacturing plant, where the batch size can be a ton or even more. At Aegis, the lab, a kilo lab, and the pilot plant belong to the R&D, while the large-scale manufacturing plant belongs to the production directorate. Here I have listed the characteristic jobs in the field I have mentioned, and it relates or reflects to the job shadowing program Gabi has mentioned, so that you have an overview what kind of educational background we need in the various jobs. So as regards the drug substance technological development, we employ preparative laboratory technicians with a secondary school education level, and the R&D chemists and the head of the laboratory are at least Master of Science, but preferably PhD. In the Kilo Lab, the situation is roughly the same, but we use technology development engineer as a description for the job for most of the colleagues. While in the pilot plant, the operators and the team leaders are with the secondary school degree background. On the other hand, the technology development engineer, the plant technologist, and the plant manager are with university education. On the analytical development side, we call laboratory technicians those who have a secondary school degree, and R&D analysts with the university background. And the drug substance production, the jobs are roughly the same as in the pilot plant. So these are the main jobs, and as Gabi mentioned, we are ready to ask our colleagues to talk about their jobs, their everyday tasks, problems, problem-solving skills, and aims, the infrastructure they use. So if it might be interesting for the teachers, then they are welcome for this program. I have talked about drug substance, but drug substance is only a part of our final product, which is the finished dosage form, so a tablet or a capsule, or there are other finished dosage forms also available, but these are the main ones for Aegis. And our pride is that with our finished dosage forms, we have won the Hungarian Innovation Prize 10 times, 8 times the Innovation Prize and 2 times the Innovation Grand Prize. And the last occasion is a very recent one. It happened in March this year, that with 2 combination products, with the rosuvastatin ezetimibe fixed dose combination and the atorvastatin ezetimibe fixed dose combination. Both of them are for the treatment of high cholesterol levels. So with these 2 products, we have won the Innovation Grand Prize. It was awarded in the Hungarian Parliament to the CEO of Aegis. So I think that this Innovation Prize and the fact that we have won it 10 times demonstrates that the R&D and the routine production and all the corresponding fields that are also necessary, of course, for marketing these products, work at a high scientific level at Aegis. So we will be happy to give a deeper insight into, for the teacher colleagues, if we find an occasion for that. So thank you for your attention. That was the presentation of Aegis, and we are of course open during the discussion to highlight with what ideas and what kind of help we can offer. Thank you.
Thank you very much indeed. This was also a very informative, good talk. And I can tell you that these 2 big pharmaceutical companies are for-profit companies, as they emphasized it. And they are competitors on the market. And the competition is hard. It's very tough. So you can imagine how big our problem and their problem is, that they are ready to participate in the very same project to help us all to develop something that is good for the teacher education. And thank you very, very, very much in advance and for today's contribution as well. And now it's time to say goodbye to our colleagues who participated online and from abroad. And the Hungarians can stay in the Zoom meeting, and they can form a small group as well online, and they can discuss the same questions as we will hear, and they can also come up with some ideas when they are summarizing the today's ideas. So we say goodbye to the to the colleagues from abroad. The Hungarians can stay, and now we are having a little break, and meanwhile we can form the groups, the little teams who will discuss the ideas, and then in the end we have to produce, of course, something, a summary of today's meeting, which would be the base of our base of our work here when we start to develop the modules and the mobility program. So thank you very much again. Thank you for your attention and your participation, and see you at the next hybrid seminar. And bye-bye. Thank you. Bye-bye.